In this video, we're going to address bases and how they react in water, or weak bases and how they react, and how the equilibrium plays a role in weak base pH calculations. Okay, so now just as the acids have a reaction, a general reaction, so do bases. Okay, now kind of ignore all this. All these blue lines and red lines. But the point is that a base, here we have ammonia, a base plus water is going to react to form the base ion as it added the proton plus OH. And so this guy, hydroxide ion. So the hydroxide ion is the thing that is controlling the pH of the solution. So it's the creation of the hydroxide ion that we are concerned about as chemists. Okay, so anytime there is a base reaction, or there is a base doing something, a weak base, that's the type of reaction you need to show. Okay, and so just like there's a Ka, there is a Kb. Here is the Kb. And again, products over reactants. That's what we have, products over reactants. These were the products, these were the reactants. Okay? And so let's take a look at how specifically this problem works. Okay, so here's what we are going to do. We're going to look at ammonia. Okay, and we are given that the Kb equals 1.8 times 10 to the minus 5. Okay, if you've seen the Ka of acetic acid, it's also 1.8 times 10 to the minus 5. That's just coincidence because this is a Kb, the other one's a Ka. So don't think that all the Kas and Kbs are always 1.8 times 10 to the minus 5. They vary tremendously based on temperature and based on what acid or base you have. But anyways, the Kb of this is 1.8 times 10 to the minus 5. And we have a 0.15 molar solution. So what we can do is we can set this problem up. Okay, so let's give it a shot. So we're going to do, I always do that. We're going to do ammonia, NH3, which is the base, plus water, H2O, is in equilibrium with NH4 plus, that's the base with an extra proton added, making it positively charged, plus H3O plus. Whoa. Not H3O plus. That would be an acid. Plus OH minus. Yes, that base reaction will never change. I broke my cardinal rule. Never change. Anytime you're doing a weak base equilibrium problem, this is the reaction. Base plus water reacts to form the conjugate plus hydroxide. Okay. Now, we were given that the initial concentration of ammonia was 0.15. Let me just double check that that's right. Okay, so go here. Let's see. Yep, 0.15 molar. Okay, so that's cool. Okay, and now water. Do we worry about water? No, because water is a liquid. It's not aqueous, nor is it a solution, or is it a gas? And then how much ammonia do we have to begin with? 0. How much hydroxide do we have to begin with? 0. Okay, so now we fill in the ICE chart. Well, again, anything with a 0, we shift towards the side with the 0. And so it's minus x, let me write ICE, okay, plus x, plus x. And if you can see where we're going from here, feel free to pause the video and see if you can get there. Okay. And so at equilibrium, this is 0.15 minus x. This is x, and this is x. Okay, so now we want to find the pH of this solution. Well, if we're going to try to find the pH, that is going to be related to this column. That's the hydroxide ion concentration. So we need to do Kb equals products, the concentration of NH4 plus times the concentration of hydroxide all over the concentration of NH3. Okay. Now we plug it in. So I'm going to plug in some values, and we're going to go. Now we don't have all the numbers, but we do have x's and stuff. We have Kb 1.8 times 10 to the minus 5 equals, let's make sure that you can see where I'm getting these values from. So this is the Kb that was given. The equilibrium concentration of ammonium ion is X. The equilibrium concentration of hydroxide ion is X. And the equilibrium concentration of ammonia is 0.15 minus X. Now we can take a shortcut here. The shortcut that we can take is we can say that X is very small. If X is very small, 0.15 minus X is going to give us still just around 0.15. So in future videos, you may hear me refer to the 5% rule. Typically, we can assume this is very small if it's less than 5%. So anyways, but we assume that this is very small. So now we can do some math. Okay. Now I'm gonna pop in my calculator so that you can see what it looks like when I put it in the calculator. And I'm gonna do this. So it's 1.8 times 10 to the minus 5. Now we're going to multiply this up times 0.15 equals x times x, x squared. Okay, so let's do that. Okay, so it's 1.8 times 10 to the, E means times 10 to the, and I use it all the time in my calculator, times 10 to the negative 5 times 0.15, and so that's going to equal 2.7 times 10 to the minus 6 equals x squared. Take the square root of both sides. Okay, so the square root of this and the square root of that. And so we do the square root of 2.7 times 10 to the negative 6. And that's going to equal 0.00164. Now that equals x. Now a lot of times students will stop there but not answer the question. The question asks, what is the pH of the solution? Let me just double check that that's what it says. Yep, what is the pH of the solution? Okay, well, so we're not quite done. We do have X, which is great because that will lead us to what we need, right? We have X. That's the concentration of hydroxide, but it is not yet pH. So this equals the concentration of hydroxide ion. Okay. Now from here we have to know where we can go. We can do one of two things. We can either calculate the pOH directly and then go to the pH, or we can calculate the hydrogen ion concentration or the hydronium ion concentration and then calculate the pH. Either one is acceptable, but I prefer to calculate pOH because the math is just a little easier. So pOH equals negative log of the concentration of hydroxide ion. And so this is the negative log of 0.00164. And that equals the pOH. So we're going to do negative log of 0.00164. And we get that the pOH equals 2.79. Okay, round up. Now, we're still not done because we don't have the pH. So let's calculate the pH. What we know is that pOH plus pH should equal 14. And this math is fairly straightforward. So you have 2.79 plus pH equals 14, and you subtract. So you get that the pH equals, and I guess I'll even use my calculator for this, although I don't have to, but 14 minus 2.79. Okay, and so that equals 11.21. Okay, so that's your pH. So it's about using the equilibrium to get us to values that we can get. And so this is how you calculate pH of a weak base.